Hi, welcome back to LeetCode. So in this video, I'm going to discuss LeetCode problem 3619. Count islands with total value divisible by k. So before solving this problem, please try to solve count number of islands in a matrix in a grid. Okay. So the problem statement is almost same, but here actually we have to do something else. Like we have to be the visitation and the algorithm will be same, but we have to calculate the other thing here, actually extra things. Okay. So you are given an m cross n matrix grid and a positive integer k. An island is a group of positive integers representing length, okay, that are four directionally connected, horizontally or vertically. So that means this is actually one cell. So this cell will be connected to this cell will be connected to this cell, and this cell, right? So so length means, so this will actually greater than equals to greater than 0. X is greater than 0. That means actually this is actually length. And 0 and positive integers, and anything else means 0 or -1, that is actually water. Yes. So the total value of an island is the sum of the values of all the cells in the island. Okay. Return the number of such islands with a total value divisible by k. So first of all, if we solve the already solved the first problem or the previous problem that actually mentioned the count number of islands, so then actually we identify that which island actually, like which cell actually part of which island, we can actually identify that. Here actually what I will do extra, that I have to do the sum of the like sum of the cell in the island. So for this example, here actually 0 means water, and non positive actually means actually part of land. So these three actually creating one island, correct? So what is actually the sum of that? 1 plus 2 plus 5, so that means actually 8. Okay, so this 5 actually alone creating another island. So the sum of this actually is 5, and here actually this actually creating another island, right? So the sum of this 1 plus 4 plus 7 plus 2, so that means 2 plus 4 6 plus 7, it is 13, 22 plus 15. Okay, here actually you can see that 7 and 8 not actually part of the same island, because 8 is not connected to the horizontally or vertically, it's connected diagonally, right? But they mentioned that diagonally part of another island. If it is connected, but it will be part of another island, it will create new island. So this will be create a new island. So this is 8. So what is actually k? K is actually 5. So is this this island, the first island, what is sum? 8. 8, it is divisible by 5? No. This 5 is divisible by k? Yes. So this will be counted. So this will be one answer. So this means this will be valid island. Okay. For this third island, what is the sum? 15. 15 modulo 5 is 0, 0. Yes. So this will be another valid island. Next is 8. 8 modulo 5, it is 0, is 0 to 0. No, this is not divisible by k. So this will not be counted. So how many actually island actually out of, how many total island actually possible? 4. But which how many actually island actually the sum is divisible by k? That is actually only 2, right? This island and this island. So that's the output will be 2. Got it? So how will you do this? So sorry. So we actually have some matrix or grid, right? So I will visit like one cell or one cell will be part of only one island, right? Either part will be an island or it will be a water. So that's why I have to take another visitor array or visitor vector. So actually initially mark that this is all actually false, not visited, right? So this will be false. Now what will do? I will actually iterate from left to right. Okay. So suppose this is actually first cell. So this is false. So this is not actually still not visited. So first we'll check that this is actually land or not. If it is land, then I will check that who is actually other cell actually part of this current island. Okay, because this is creating a new island. This cell, this will be creating new island, but it is possible that this will be part of the same island, right? Because this is connected. So that's why I will actually iterate all the actually cells that are actually connected with the current cell and mark all of this as a visited as a true. Okay, so this will be true, and I will also calculate what is the sum of that, sum of all the cells in the current island. Okay, so I will get one sum, and I'll check that if it is divisible by k, then actually I will actually increase our answer. Got it? The simple. So if you solve the first problem, the count number of islands, then it will be easy to understand how to optimize, like how to solve this problem. So that means again, here also we will take another visitor vector, or actually mark all the nodes actually as a visitor as a false, and I'll iterate from left to right or all the cell one by one. So if the current cell actually is false and this the current cell actually has a land, so I will actually DFS. You can actually use the DFS, BFS both. Anything actually okay, because only one cell will be visited only once. Because I'll actually take this visitor vector, so I will mark this as a visitor as a true. So I will not visit this again, any cell again. It is already true. So that's why it's okay. You can actually use DFS, BFS both. Any one of these. So then actually I will visit and I will check that in the current cell, in the current island, which is actually part of the current island, which not actually part of the current island. Then I will take the sum of that, and ultimately after when actually the visitation will be completed, I will actually done the what is the sum of the all the cells, and I will actually check that sum is divisible by k or not, right? So let's see the same. So first of all, our answer will be 0 because I have to return the number of island that actually sum is divisible by k. So initially it is 0. And first of all, find out what is the number of rows in the matrix and the number of columns. Okay, so I have to take again the same size of visitor vector, 2D vector r, and size is r cross column, and initially mark this as false. All the cells actually not visited yet, so initially it is false. And now iterate all the cells I comma j. So that's why I'm starting from I is 0, I less than r, and j starting from 0, j less than column. And I'll check that the current cell I comma j, it is a land, that means greater than equals to greater than 0, positive. They mention that positive integer a positive integer indicate that this will land. So that's why I'll check that the current cell I comma j is greater than 0, that means this will land. So this will create a new island, but when it will create a new island, if it is still not visited, right? Otherwise it already part of another or any past, you can say that any other island, right? So that's why I'll check that the visited of I comma j is still false. So that means this is going to create a new island. So then actually I will call this helper function. What will it return? It should return this what is the sum of the current island. Okay, so I know the starting cell, it is I comma j, and I will return also pass the visited vector because in the future I'll check that I have to skip the already visited node, right? So that's why I have to pass this and mark all the visited node as true. And I'll get from this helper function, I'll get the what is the sum of the current island. I'll check that this sum is divisible by k, and so that means modulo of k should be equal to 0. So if it is equal to 0, then this island will be counted as a valid island. So I'll increase the answer plus plus. Ultimately, this for loop actually it will end. I actually have the answer variable that actually return the how many actually valid island actually I have. Got it? And return that. So this helper function, how it's working? Here actually I actually use the BFS approach, right? Yes, stack. So in the stack actually, so here actually what I will get the what is the starting node I comma j, and the visitor vector and the grid. So to know that this cell actually is a part of land or water, right? So that's why I have to return the sum. So that's why I've taken a variable sum, long type 0, initially it is 0, and mark this current cell I comma j as true, and store this I comma j into the stack. Okay, so there are 4 directions are possible. They have mentioned that vertically or horizontally. So that means, so this 4 cell actually possible. So this actually suppose I comma j. So this will be same I, and j will be shifted to j minus 1, and this will be same I, j will shift to j plus 1, and this will be I will be shifted to I plus 1 because I am going to downward, and this will be j will be same. And here also the I will be shifted to upward, so this will be I minus 1, and j is same, right? So here actually you can see that I have to add 0 comma minus 1. Here actually I have to add 0 comma plus 1. Here actually I have to add plus 1 comma 0. Here actually I have to add minus 1 comma 0. So I need to two vector, one for x, one for y. So for the first 0 and minus 1, for the next 0 comma plus 1, for the next minus 1 comma 0, and this is actually plus 1 comma 0. So I have taken two vector, one for x, one comma y. So dx 1 comma 0, minus 1 comma 0, 0 comma 1, 0 comma minus 1. So I know the four direction. So I can actually go any four direction in from the current cell I comma j, any random cell. So that's how while still stack is still not empty. So I actually have some node in the current island, part of the current island. So I actually have x comma y. So I'll pop this from the stack, and I will add this sum into the current value into the sum. Okay. Now I have to go to the adjacent node from the current cell. So there are four directions possible. So that's why four direction size is 4. So I have to know the new vertex, new x and new y. So the new x, current x is x, and then direction is going to suppose 1, and 1 is another new y will be the current y plus the new direction. So it will shift it to right side or left side, something like that. So I'll check that this cell, the current next point is varied or not. So how can I validate that? So I'll check that new x is greater than or equal to 0 and it should be less than r. So then it will be part of the matrix, and also the new y, it should be greater than or equal to 0 and less than column. Then it will be part of the actually the any cell in the matrix or the grid. Then I'll check that this cell actually already visited or not. Otherwise I should not visit the same node again, because I have already counted the value in the sum variable, right? So that's why I'll mark this. Okay, this is still false, and this is actually land. The new cell is actually part of land. So then it will be part of the current island. So I'll check that the new x grid of new x and new y, it is greater than 0. Then to part island. So I'll mark this as true and push this into the stack. Whenever it will inside into the stack, so it will be counted in the sum at least, right? Because I will run this while loop. Still, actually, I have some element in the stack. So that's why I'll push this into the stack directly. Got it? So after this while loop, I in the sum variable actually have the total sum of the values in the that part of the current island. Got it? So this is clear. So this is simple actually. So if you found this video useful, you can actually subscribe the channel and like the video. And also, what is the time study for this? So here actually this for loop will nested for loop. So it will be r comma column, and the worst in the best case or the worst case, you can say that each node will be visited only once. So it can go up to r comma like it can be visited only r cross c, like makes all the nodes will be visited. All the nodes are part of the island. So it will be r cross c. Got it? The time study clear? I have shared this code in the description. You can check that also. Bye. Thank you.